All right, so in this next one, I am going to save my writer's cramp here, and I'm going to write that my LCD is equal to this right here. And I'm just going to use the word LCD instead of carrying along this denominator. So this is a subtraction problem, so I'm going to go plus and then a minus 1, which is going to get distributed through here so that I can get that subtraction distributed. So we have 3x minus 2 plus a negative 2x and then plus 1. And this is all over my LCD. And then I'm going to simplify by combining like terms. I have a 3x here and a negative 2x here, which makes an x, and then a negative 2 and a positive 1, which makes a negative 1. Now, instead of writing in the LCD, I'm actually going to factor this thing. So I need the factors of 6 that give me a difference of 5. Well, that would be an x with a 6 and an x with a 1. And that is going to be a positive 6 and a negative 1. And so now what I'm going to see is I'm going to see that this one and this one can cancel. Now be very careful here. This is a 1 over x plus 6. Many times what I see students do is they'll write x plus 6 period in a sentence, but what you have to remember is that this x plus 6 is in the denominator. It has to stay in the denominator. So don't just write x plus 6. It's 1 over x plus 6. All right, in our next one here again, I have plus and then a minus 1 times this. So this is going to get to distribute through. So I have 2x squared minus 25 minus x squared. And that's all over x plus 5. Remember, I'm carrying along the common denominator. I'm not adding them up. I'm not writing 2 of them. I'm carrying along a common denominator, just like when we added fractions. 2x squared minus x squared gives me an x squared. And then I have minus 25. And that's over x plus 5. Now I see a binomial, a difference, 2 perfect squares. So I'll factor that. I have the product of conjugates, so I need 2 binomials for those conjugates, and I have 1 with a plus and 1 with a minus. And then that's over the common denominator of x plus 5, and I can see the x plus 5 and the x plus 5 cancel. And this one really does give me just a binomial as an answer, because that binomial this time around is in the numerator, and so that is just my final answer. Okay, now the next thing we're going to do is we're going to learn about building higher terms. So remember the fundamental theorem of fractions. The fundamental theorem of fractions tells us that if we multiply both the numerator and the denominator by the same thing, then we come up with an equivalent fraction. So in other words, if I wanted to build a higher term for 3/5, say 2/15, I said, okay, 5 times what gave me 15? Well, 5 times 3. And then 3 times 3, and that gave me 9/15, and that's a higher term, right? So fundamental theorem of fractions. Well, we're going to use the fundamental theorem of rational expressions to build higher terms. And this will just be one of the many steps in our process. So first of all, we're going to find or know the new denominator. Then we're going to find that missing c by asking what must I multiply by the old denominator to get the new denominator. And then we'll multiply by that c to get the numerator, and then we'll expand. So here I see, okay, I currently have an x minus 1. I need an x minus 1 times an x plus 5. So I'll have to do times an x plus 5. And then whatever I did to the denominator, I also multiply that by the numerator. And then here I want to expand it out, so I'm going to distribute. So I have a negative 6x minus 30. And there's my new higher term. All right, why don't you go ahead and practice with B, C, and D, and when we come back in the next video, I will do those with you, and you can check and see if you got them correct or not.